Take a long time though. I'm not sure we're gonna get today.
How many of us got woken up at 2 in the morning by the flash flood warning?
Oh, yeah.
So Kevin and I are going to do a two-part thing here. This is the Lawrence, Kansas tornado this year. I'm going to go over some of the mesoscale details, some synoptic setup, some of the tools we used in the office, and then Kevin will do some of the damage survey after action stuff. So we'll go ahead and get started.
Now we got a large, very large tornado, large wedge tornado, southwest of Lawrence. I am at N1000 Road, 1100 Road, just south of Lawrence, just south of Highway 10. Very, very large and dangerous tornado coming in to this. It's going to be coming in just south of Highway 10, Matt.
Yeah, that's what we've got it up on the screen right now, too. We can see that. Here's your large and dangerous tornado that Dylan's been talking about. It's a very large tornado. It is on the ground. This is a fairly populated Douglas County area, and so this is not far outside the city of Lawrence. You can see it passing. This is zoomed in a little bit, well beyond the actual city, but you can see all that circulation showing up right there. Large tornado on the ground south of Lawrence, right?
Who's had the sweaty palm, heart racing, can barely focus because they're so nervous about what's going on? Not only do we have a large wedge tornado on the ground, I put my own wife, my own dog in a tornado emergency. I put half of our staff where they live in a tornado emergency. It was a very high stress environment in our office that day. So go ahead and I was giving you the answer before the question, but we'll go through the question now. So some of the synoptic and mesoscale features that we had that day. There was a broad, long-wave trough across the western CONUS with a embedded 60 to 70 knot mid-level speed maximum coming across the high plains into the central plains. Some weak mid-level shortwave there across parts of southeast Colorado into portions of central Oklahoma or so. So the overall ascent was modest at best for convection that day. Going a little bit lower, we're down to 850. We have a broad warm advective pattern across basically the eastern half of Kansas down into Oklahoma. So we do have some decent low-level moisture that's being advected northward, aided by a 25 to 30 knot low-level jet by late afternoon or so. So this is just a radar loop from the morning into the afternoon. We had some low-level jet warm advection, regenerative convection through the morning into the early afternoon hours. That was also aided by some of that ascent that we were getting from that lead shortwave coming around the base of the trough out west. So this is by midday. This is 1730Z. So then you can see by late afternoon we were starting to get some convective development across eastern Kansas there. But the overall setup was we had that regenerative convection that was reinforcing that boundary to the north. But we had your classic triple point setup across parts of central Kansas, just west of Salina near Hayes, with the dry line extending southward from there. You had your Pacific front southwestward from there, and then your stationary front / warm front that was being reinforced by that elevated convection earlier in the day. So the question that we had sitting in ops was, we had an expansive stratus shield from that elevated convection and warm advection that was just allowing for stratus to persist across the area most of the morning into the afternoon. We didn't know if we would exactly get enough clearing for convection to develop later in the afternoon. But we were monitoring satellite through the day. I noticed we did get some thinning by late afternoon or early afternoon, and then it set the stage for us, just some open warm sector convective development there across eastern Kansas. And this would ultimately be what would be the Lawrence area tornado. So as far as the environment that these storms are developing in, plenty of cape, steep lapse rates, upwards of 4,000 joules per kilogram of mixed layer cape, had plenty of deep layer shear, especially since we we're seeing more open warm sector development. It wasn't necessarily the deep shear orientation was not off any boundary because these storms weren't developing on necessarily any boundary. So the likelihood that they would be discrete / semi-discrete was pretty high. Furthermore, looking at low-level shear, with the surface low across central Kansas, we obviously had decently backed winds across eastern Kansas with upwards of 200 to 300 effective SRH by late afternoon. How many of the offices ever look at Scram? It's the latest deal. So this actually helped us through that day. Are you guys aware of the unconditional probability or the conditional probabilities at all of Scram? So luckily, the HUR and the RAP are both generating convection, so we were getting some pretty significant signals for a tornado potential across far eastern Kansas by late afternoon. This is 4 different runs, late morning. All 4 were hinting at near 20 to 25 tornado probabilities in the Lawrence area. Basically what the Scram is, for those that don't know, it's looking at a climatology of severe weather reports and looking at the environment in which those were reported in, what the environmental conditions that those occurred in, and then giving a forecast 4 hours in advance. And based on the climatology, the probability of those, of having a severe wind, tornado, or hail report in the next 4 hours. And so these are 4 different timestamps of 4 different model runs. Top left was the 15Z, 16Z, 17, 18Z. So we had a very consistent signal across far eastern Kansas of a tornado event later on in the day. All right, now this is where I'm kind of going to go against what things were talked about earlier today about as far. We actually in our office have taken what Ariel Cohen and his dad developed. This was a simulated tornado probability and wind speed model that Ariel and his dad and a couple other folks at SBC developed, basically taking into account the environment in which your storm is in, along with the characteristics of a couplet. So Bill Gargan and myself, we went through 180 tornado cases, varying degrees of EF rating, varying degrees of where they were located. It was all across the Central Plains. And we were able to do some statistical analysis based on the tornado probabilities that we gathered from all these different all these tornado reports, upwards of an hour prior to the tornado. And then we were able to distribute these in box and whisker plots to try to determine if there's a signal between using this combination blended approach of environment and couplet characteristics. So the output right now that we use is pretty basic. It's a Google sheet and it's pretty simple inputs. Basically you're looking for the maximum outbound of a low level circulation, the maximum outbound, maximum inbound, the height of this above the radar level, the diameter between your max in and your max out. And then as far as the environmental parameter that's ingested into this is the effective layer significant tornado parameter. And then some other that are judgment based is if the circulation is well defined or if it's more diffuse, you either do a 0 or 1, and then if there's a TDS noted. So then that plots over into another Google sheet, and it'll give you the tornado probability and estimated wind speed. We focus more on the tornado probability throughout this research project. So this is just an example. This is the Lawrence tornado as it developed southwest of Lone Star Lake. But just basically how we envisioned using this would be more of a radar assistant, just another tool in the toolbox using some of the features that TWIP has introduced. Just another tool that you can use, but this is more so the use of a radar assistant where they're looking at GR level and they're just slice by slice, scan by scan, entering this into a Google sheet and getting you probabilities slice by slice. So not only are you seeing the real-time probabilities, but also how they've trended over the last 5, 10, 15, 20, 30 minutes, just to try to help aid you in confidence in issuing that tornado warning. So this is the effective significant tornado parameter by late afternoon, evening, it had increased to a 3. So we knew we were right for the potential for significant tornadoes. So after we did all of the 180 tornadoes, this is kind of the probabilities, the trends that we saw, and we distributed them based on this color coding. And some of the trends that we saw was if you were getting a tornado probability of near 10, especially 10 to 15%, this was a pretty significant signal, upwards of 20 to perhaps 25 minutes prior to tornado genesis. And in this case, I'll show on the next slide. The radar assistant, Brandon Drake, was my radar assistant that day. He actually did the tornado probabilities throughout the entire life cycle of the cyclic supercell, which in this case didn't necessarily give us increased lead time for Lawrence. It just gave us more confidence that this is still a tornadic storm. But as you see in the magenta, if I go back, the top 90th percentile we've reserved for more of the very high end. You have a very favorable environment for SIG-TORs, along with you have a very strong couplet co-located with this strong environment. And unfortunately on this Lawrence day, I'm going the wrong way, sorry. We did end up southwest of Lawrence. We did end up getting to that, the magenta color, which we've reserved for those very strong environments with strong couplets. And this actually was just another tool that helped me get more confidence that A, we're getting reports that we have a large, probably significant tornado ongoing, but it also gave me increased confidence that this model is also confirming the reports that we're getting. So based on those two things alone, we went ahead and did a tornado emergency with its proximity to Lawrence. So now I'm going to turn it over to Kevin for the survey results. Did I skip it? Oh, sorry.
That's the best part, in my opinion.
Sorry. There it goes.
Yes.
We'll play one more time.
I was going to say, while I watch what's going on southwest of Lone Star Lake here in particular early on, this is going to come into play in the survey here in the next couple of slides. All right, it's my turn. So as we as NWS meteorologists know, the job wasn't done when the storm dissipated. We had to coordinate survey teams to go out and look at the damage and rate the damage because we're all damage experts. Remember, jack of all trades. So we had two survey teams go out, one from the Topeka office and one from the Pleasant Hill office, as our CWA border is the lovely Kansas River right here. So after the initial ground survey, which lasted throughout the day on May 29th, this was the initial tornado track that we came up with. And looking at the damage indicator points, it was pretty well covered across most of the track of the tornado. I mean, this was a 30-mile long tornado track through a very relatively populated area. It's a lot to go through on a damage survey. If any of you have been on damage surveys, you know how long they can take. Everyone wants to tell you their stories. So to get this detail on the first day was pretty good. It's pretty remarkable that we were able to do that. And based on that, we had the highest rated EF4, which actually occurred just to the northeast of Douglas County there. And again, the damage survey, the ground survey, was focused primarily on the structures that were hit, finding the start point, the end point, and the highest EF rating, and that's what they did. And so these are just some of the pictures of the survey damage. This was the EF4 damage by Linwood in Leavenworth County. And a lot of these pictures are also in Douglas County, Leavenworth County, of primarily EF2, some low EF3 damage as well. However, we didn't stop there with the survey. We immediately after the event on May 29th, we ordered satellite data to cover the entire track of the Lawrence tornado. And this can be done by any NWS office. How many of you guys have ordered satellite data before? Not as many as I want to see. So this is a process that we can use through the USGS. There's a wiki page on the Central Region Rock page that can help you do this. This is just an example of the form I filled out to order the satellite data, and here's the transects we ordered. We wanted to cover earlier in the track just in case there were earlier tornadoes that we had missed, and we wanted to try to cover with the satellite data. But again, the main interest was the Lawrence area. And it became quickly apparent that the ground survey needed adjusting. So by June 1st, between secondary surveys that were done and videos that were produced and the radar data, we were pretty confident we actually had 2 tornadoes. We had an additional tornado that had formed earlier from a different cycling of the mesocyclone, and as it occluded, that tornado had remained discrete and steady state and continued as the new mesocyclone, which eventually became the main EF4 tornado, ramped up, and it continued along the south side of Lone Star Lake. That's why I asked you to pay attention to that radar loop. Because from a ground survey perspective, this looked essentially like continuous damage. The difference between these 2 points is about 100 to 200 feet. They're very, very hard. It was essentially impossible to tell from the ground. This was essentially a continuous swath of damage. And this was the earlier tornado that, for those who were paying attention to this event, this is the one that rolled the storm chaser van south of Lawrence and injured, 9, 12 people were injured in that van, Brian, do you remember?
There was 18 injuries in Douglas County. All 18 were people trying to see the tornado.
There's enough stats for you right there. We also went and filled in a couple more DIs across Douglas County. We actually found some damage that was actually rather close to EF4 in Douglas County. We rated EF3 based on the fact that the sill plates were garbage on this house. But this is a picture of some of the damage on there. But again, using the combination of radar data and additional surveys, I mean, we did 3 additional, I did a survey and then someone else from another office did another survey to help fill in these gaps here. And then finally we got the satellite data in. The first rounds came in on May 30th, which did not cover most of the path with the high-res data. We had 10-meter data that came in on May 30th that covered the entire track from the Sentinel satellites, and a special coverage from the Pleiades satellite that came in with half-meter satellite imagery around Lawrence. So we were able to construct partially the track. But finally on June 13th, the full half-meter worldview satellite imagery came in that covered the entire Lawrence track. And that allowed us to really get into the nitty-gritty of the details of this tornado and see the details that you just could not see from the ground. And these are some pictures of the satellite imagery from the event. Looking at the home damage across the area. You can actually see squirrel marks in the fields, tree damage, especially lovely convergent tree damage here. And again, more structural damage and squirrel marks in the fields there. So this was used to augment the ground survey. And finally, we came up with our final tornado track from the Lawrence tornado, using the polygons within the DAT. Again, this is all a combination of both the satellite imagery and the ground survey to combine to construct this entire polygon track in as much detail as we possibly could with the data we had. And so this is an example of where you can leverage all your ground surveying sources, ground and aerial surveying sources, to really put together these amazing tracks that can be used for briefings, for partners. Anybody can use these to really use this for research purposes. These are amazing tracks that help really hone in, especially that an EF4 tornado was not EF4 from the beginning to the end. The EF4 point is right there. And for the vast majority of the time, it's the blue and the green, which is EF0 to EF1. So really an educational tool for the public to showcase what tornado damage is all about. And I believe that is the end of that section of the talk. Any questions? Hey, BB.
Hi.
Hi.
I just wanted to say more comment, of course, because that's what students do, that having been a former resident of Lawrence and having a lot of friends in that area, some who were hit, I just wanted to say it was a really good example, I thought, of the integrated warning team. 2 offices, 2 media, main media entities, just so much communication, and I thought it was really good. I just wanted to point that out too. There was nobody I talked with who wasn't aware of what was going on. So that speaks, I think, quite a bit.
The thing that we got on the original survey was we went to 40 homes or so. Every resident got the warning based from WIA, every single one. That was pretty alarming, that the cell phone is the way people are getting alerted now, 100%. Even, it didn't matter age.
Brian, how did you guys handle it? You were working the event, correct?
Mm-hmm.
And so you put the tornado emergency for loved ones.
Yeah.
How did, at the office at the time, how did you guys compartmentalize that when it comes to doing your job, but also knowing your loved ones could be hit? Was that something that was a high stress in the office and people thinking about that?
Well, to be honest, I had notified my wife, like, before it was even entering Douglas County that, all right, pay attention, this is on its way. and so then she was paying attention after that. I mean, I can tell you it was a heart pounding 30 minutes, but we got it done. It was a very open, collaborative, it was a very open conversation with everyone in the office. Like, okay, I have this drawn up. You guys okay with this? I had drawn the tornado emergency up, and we basically did about a 15-second yes, 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 and we did it.
So so the people in the office were still able to keep their situational awareness?
Oh, absolutely, yeah.
during
I think during this
because
event,
in that situation, I don't know if I could, I mean, knowing that, but-
right. Yeah, we probably had 8, I think, working that day, so we had plenty of people in the office. Aaron?
Great talk, guys. One comment and one question. The comment, to me, these things always illustrate, when you talk about the survey data, how there's a difference between saying underrating of a tornado along its entire track due to limited DIs versus, tornado intensity can change sub-minute.
We noticed
There's
that.
Dow data showing 20-second bursts, and then it's gone.
Yep.
And that just because a DI shows 1 and then 400 meters away it shows 3, that does not invalidate that EF1, because we're talking about scales. The other question I had, and this is probably more to a question, how much dual pole data were you looking at in real time?
In real time, I was looking at none.
Okay.
I was looking at SRM, and I was doing minute-by-minute updates after up to the point where it became, okay, this is
I thought you
it.
guys had radar indicated TDS on that morning at one point.
Yes, I was saying, prior to the wedge going on the ground, I was absolutely looking at TDS, or at dual pole data.
The reason I say that is, now this was in Pleasant Hills area, but even towards the end, you saw the ZDR that was well-defined all the way through Lawrence become disrupted, and about 10 minutes later, the ZDR just goes away completely. And that's a messaging tool to say, all right, for Bonner Springs, maybe this is gonna end. So if you're not looking at that, you can extend out something that there were signals ahead of time what was gonna occur. So just
Yeah, the thing with the ZDR arc, and at least me personally, I need a lot more examples so I can actually utilize it in real time.
That's that first category I talked about. It's
Yeah.
too much of a fire hose for some people, and that's where we get to the training part.
And I
We'll
think
we'll
it
get you
just-
there, Brian.
Just repetition, I think.
We'll get you there, Brian. I
Yeah,
promise.
with that said, Aaron, as the tornado did dissipate as it went into Kansas City, because, you said the ZDR got disrupted, and the tornado did dissipate or lift as it went into Kansas City, but then the interesting thing about it you may want to look at, or somebody may want to look at, is after it got northwest of Kansas City, it did redevelop in another tornado.
Northeast.
Supercell.
Northeast.
Northeast of
Right.
Kansas City.
I was just
yeah.
talking about that
Yeah.
phase of
Oh, sure, yeah.
dissipation. Anyway,
Yeah.
very good, guys.
Thank you.
Thank you, Brian and Kevin.
I don't leave.